3.4a. Last time we talked about the relative max and the relative min. Today we're going to talk about the absolute max and an absolute min. Notice this is a continuous function, and our endpoints, we have the highest point is absolute max and our lowest point is absolute min. Now these don't need to occur at endpoints. For example, let's say we have a function like this. This is our absolute max as well for this particular function. We have something called the extreme value theorem. Extreme value theorem. And the extreme value theorem states a continuous function defined on a closed interval from some number a to some number b must have an absolute maximum and minimum on the same closed interval from a to b. A continuous function defined on some closed interval from some number from a to b must have an absolute max and an absolute min on that same closed interval from a to b. So let's do an example. Find the absolute, I'm just going to abbreviate, maximum and minimum values of f of x equals x cubed minus 3x plus 2 on the closed interval from -2 to 3/2. Okay, so what we do first is we take the derivative. F prime of x equals 3x squared minus 3. What do we do next? Right, we set it to 0. We have 3x squared minus 3 equals 0. We take out the 3 and we have x squared minus 1, and that continues to factor to x 3 times x plus 1 and x minus 1. So where does all of this equal 0? Well, that's where x equals -1 and x equals 1. These are critical values. All right, so the reason why we found our critical values is because our critical values can be an absolute or absolute min, just like here, or they could be at the endpoints. So we're going to test our critical values and our endpoints to see where our absolute max is and our absolute min is. So let's do that right now. Okay, so we're putting these into our original function, which is f of x equals x cubed minus 3x plus 2. So now we're going to test our critical values. F -1 equals -1 plus 3 plus 2, which equals 4. All right, now we're going to test our other critical value, f of 1. F of 1 equals 1 minus 3 plus 2, which equals 0. Now we test our endpoints. F of -2 equals -2 cubed minus 3 times -2 plus 2. And this equals -8 plus 6 plus 2, which equals 0. So these both equal 0. And our last one, our last endpoint, which was 3/2. 3/2 is the same thing as 1.5. So we input that 1.5 cubed minus 3 times 1.5 plus 2, and that ends up being 0.875. So we're looking for our highest output, which is 4. That's our absolute max. And our lowest output, which is 0. Okay, so let's go ahead and write our answer. absolute maximum is 4 at x equals -1. Absolute minimum values, there's two of them in this case, is 0. Well, we have one value 0, but they happen at two spots, at x equals 1 and x equals -2. And there's our answer.